Yes, Manish.
Okay, great. So see, we'll continue with the slide because I want to cover this slide also. Okay, and wherever the extra inputs would be required, that will be provided. Okay. So now the first question which comes to our mind is why someone is building a data warehouse. Okay, and that we discussed yesterday. Okay, that's why the business wants the data is very critical for their decision making. Next thing comes into the mind, what are the main things? Okay, even if you are as a working as a tester, okay, you will be involved into the meetings from the requirement phase itself to understand the project. Then only you can write a test plan, and then only you can prepare a test strategy for that. So someone from the testing team will be there. I mean, either the test lead or even the tester also at times. At times only the test manager, but the information will be passed upon. So the first point is identify key business drivers, sponsorship, risk, okay, and a return on investment. So all these things, the business analyst from your team or from the client side, he will sit with the customer. Okay, they are the one who is going to identify it. But at the same time, before they freeze the document, business requirement document or any other document, they will definitely going to discuss it with everyone. Even the test manager's approval will be required whether these things can be practically tested or not. So such things will, I mean, these things are going to happen, right? And this you can relate to your, previous projects also, that how the documents are being freezed. Then different subject areas with respect to that business. So this is where the architect and the domain people will come into picture. They will say equal to y then some other value. So when you check the database, you have to get all the values in the case statement. So those things can be available when you see the data model. Okay. And then based on the budget of the client, based on the you will give him quite a few options. Okay, so it's like we are not into a product company, we are into a service company. So if we are in service company, then we'll give him many options. We have the expertise in data informatics, all the tools we will give. So and then based on the budget and other I mean even the availability of the people in the same time, then the final evaluation will happen. So the DW tool and technology will be decided, and then you will do a POC on top of that, and you will present to the client, yes, like this is what we can achieve, and this is how it's going to be done. So this is like just for understanding part that how a typical project gets started. Now what happens in the beginning? Okay, so first of all, once the architect is final, okay, once the data model is final, okay, after that the database administrator will come into picture. He will design the target database schema. Okay, so there would be number of schemas under which number of in every schema there would be some set of tables. So again, the schemas would be at different layers. Okay, there is like staging layer, there is target layer. So first they will try to design the target database schema. So that's why it's written target database schema. Then how the data gets loaded into all these tables into different schemas. For that you will build a mapping. So here we are considering Informatica as the tool. Okay, so the term mapping will be used always. And then extract the transformation. Okay, then what set of rules? So the mapping will basically contain, mapping is nothing but it's a set of transformations. Okay, so in which you will write the code how to actually derive the derivations, aggregation, and everything. And then again, if the data marts are required, then based on the requirements, we are going to create a data mart also. See, we'll just discuss in the next few slides how the data warehouse is created. In terms like first, whether will you create a data mart or you will create a warehouse first. Okay. Generally, you will find that warehouse is created first and then the marts will be created. I mean, in number of projects where I have worked so far. So we'll just discuss that thing, what to create first. And then obviously you have to maintain and administrate the data warehouse. So DBA administrator will play a very important role. So these are some just industry standard terms. Okay, what is data dictionary? So if you see the Oracle architecture, okay, so data dictionary is nothing, just a collection of set of tables, specifically the metadata tables. Okay, so the metadata, as we know that it contains the information about where your sources are, where your targets are. Likewise, the ETL tool also have the metadata. Okay, same wise database also is going to have a metadata. So it will include basically the information about all the tables which are being involved. So this data dictionary here is with respect to the ETL tool as well as with respect to the database. So your source is coming from where, okay, your target is where, your ETL tool is, the mappings are where, all such informations will be there in the metadata tables. Then data mart we discussed, this is a subset of data warehouse that focuses on one or more specific subject areas. The data is usually extracted from the warehouse and further denormalized and indexed to support intense usage by targeted customers. So that's what practically happens. The data mart will be created after the data warehouse. See, initially you are taking data from the entire organization. You're staging it, transforming it, loading it into the warehouse. Once the entire data is there, on top of that, you will create a mart specific to a subject area, only HR data, only finance data, only sales data. So like that, you will now create a mart because this mart will contain specific data only. So once you write a, the HR department writes a query, okay. So in that case, he doesn't have to, the performance issue will not be there. He don't have to go and, select that data from the big warehouse. So he'll just go to the mart specific to that. This is also done for security reasons also, okay. That when one department person doesn't have to do anything with the other, so he won't be given access to, the complete warehouse. They will give just specific to their mart limited where he needs to, where he can query the data.
Manish, here I have a question regarding the data mart.
Yes, please.
So, as my understanding, so data mart is kind of a database.
Yes, obviously. See, the data warehouse in itself is a database.
Okay.
Okay, data mart is also database, and the normal OLTP system is also database. The purpose is different in all the three. Okay, OLTP is daily transaction.
Okay.
Warehouse we discuss. See, in warehouse there are certain technologies which comes into like parallelism. Okay, so Teradata provides that. Oracle don't provide. That's why Oracle is not successful in data warehousing market. Oracle has created a product called Oracle Exadata to compete with Teradata and all. But these people have gone way beyond that. So likewise, Informatica is a small company, but it's number one in data integration. Likewise, when you come with the storage of data, like in which database you are going to build it, your data, then Teradata is kind of master. IBM Netezza is there. Okay.
Okay.
After that, like IBM DB2 comes, Microsoft SQL Server. So Microsoft sells its entire tool. So these are the databases built specifically to store data in data warehousing environment, where data grows over and over and over. Okay, there is no limit to that. So to retrieve the data, how they function it, okay, like Teradata has nothing shared architecture, we call. If you want, I'll cover in one class for 10-15 minutes Teradata architecture. I will cover it. It's quite simple. Okay, you just need to understand the difference between Oracle architecture and Teradata architecture. Why Teradata is fast? Okay, why does it support so much of data? So that you will see it will become clear.
Okay. So here my question is like what you said is a data mart. So the data warehouse will be the huge records will be storing over there in a data warehouse. And in the terms of a data mart, the individual schema will be like how the department and the HR department, HR salary part, and everything will be in a different data mart. Am I right?
Yes, the data mart would be specific to a particular department or particular subject area, we can say. Okay, so they will create on top of warehouse. The
Okay.
first reason is the performance. Okay, the person who writes a query, you don't have to, see, you have to understand how the data, how SQL query retrieves the data. So these are like database administrator concepts. So it will create a virtual path. We call it explain plan. Okay, so it will search that data. It will search those joins which are there in your SQL. It will go to the processor memory. They will see there's a buffer pool. Okay, where they will see if already that query results are there. If not, it will go to the actual database. So in Oracle, it goes to database disks and everything. But we're not talking about Oracle. We're talking about like if Teradata say there are virtual amps we call. They are virtual disks attached to every amp access module processor we call. So that's the architecture right now. Okay, I'm talking about. So the query gets distributed to all the virtual disks, and then they will try to find out who have that information. Then they will send it back to the you know uh, the user. So
So
you don't have to go to the entire storage. That is the first one reason. Second primary reason is security. Okay. So I want to secure my data. I don't want to let you even fire a SQL query on the other critical data. So that's why they create specific data marts. On top of that, they do reporting. Sometimes data marts are not even created. But at times when it grows very large, in practical, you will find data marts also.
so if we create a data mart, the performance will be high, right? If we have
Exactly. The performance will be high not for data warehouse. It will be specific to that subject area.
okay, okay, okay.
As a business manager, I don't want to see they are very sensitive about the time. That's why
Okay,
these are very high cost projects, data warehousing always. Okay. So
okay,
to maintain them, to develop them, to test them, these are like highly paid jobs. So the DBS, I mean, so much cost is involved, even in testing, very critical everything. So they don't want to, like a report will take 30 minutes. They see they are not going to write SQL query. They will just click on a button, generate report on the BI tool. So they
okay,
don't sit for 30 minutes, 20 minutes. The report will come. No, they want it in maximum 2 minutes, 3 minutes, like that. That kind of SLA is there, or even less than 1 minute most of the time. So that is where, as a DBA and other people, every developer, they will think how the performance can be improved.
okay. So being a ETL tester, we need to we will be testing the data mart also, right? Not only with the data warehouse.
Exactly. See, testing will remain, concept will remain exactly same with respect to data warehouse and data mart.
Okay,
You will be given some certain test set of tables to test. You have to see where those tables are, in data warehouse or data mart. Then
okay.
you have to see in which schema those tables are, and then you have
To
to just write
joins.
your SQL query and write your joins and just do it.
Oh,
So, uh,
okay, Manish.
yeah. Then there are some terms like data mining, data model. Data mining is something advanced concepts. This is in itself, it's a science in itself. Okay. So it's a technique of finding patterns and trends in large data sets. So this is something, it's basically analysis. Okay. It plays a very important role in analytics. So we won't discuss much about mining because mining is completely a very big subject in itself. Right. So in ETL, we don't require it. Okay, so now data model. So data model is again, this is the definition it is given here, the roadmap to the data in a database. This includes the source of tables and columns and the meanings of the keys and relationships between the table. That is the most important thing. All the relationships would be there, one to many, many to one relationships, like how the one table is being, joined to others. The particular primary key, how is it being shared as a foreign key to the other table. All such information you can get from the data model. I'll see if data model is there in the slides. Otherwise, from net I will show you one data model picture. Then basic terms, data cleaning, data normalization. What do we mean by cleansing? We are actually cleaning the data. Okay, we are cleaning sometimes the data types, the formats. Okay, sometimes the duplicacy. So all these terms which are related with respect to extract, transform, and load. So excuse me. Okay, diagram is coming up. So if you have to replace any nulls, okay, if any inconsistency is there, if you have to trim the data, all these things are basic part of cleansing. In the diagram, I will cover more. Then again, normalization. So basic definition of normalization, just try to understand if this term comes ever in the discussion. So it's just to remove duplicates from the dimension tables in the warehouse. And how will you remove that? You will create a separate table and you will create a relationship between them. So the process of eliminating duplicate information in a database by creating a separate table that stores the redundant information, right? So when the table, see, data warehouse tables are so huge. So there are say 10 columns. Okay, for example, in normalization, you have defined a primary key on 3 columns. First 3 columns composite together is a primary key, right? So what normalization says is that first normal form, okay, first normal form is that suppose there is you have the Excel sheet, right, or you have you have a table, okay, columns, rows in a particular cell, okay, so you understand cell, okay, 1 second. So you try to visualize like this. There is a data in a table, okay, you are seeing row number 1. In row number 1 there are now 10 fields because there are 10 columns in the table, okay. So in field number 1, that field we call it cell. In that cell always there has to be one value. It cannot be 2 comma 3. It has to be only 2 or either 3. Then next it could be 4, 5, 6 like that, or A, B, C, D like that. It cannot be A comma B. It has to be either A or B in a particular field. Understood? So what the normalization says, first normal form says that, just for an example, if there is a table and it has 10 columns, in the first, in any field, okay, in the entire table there has to be one value. So that is first normal form. That is what defines a relational database. Second normal form says if you have defined a primary key, okay, say primary key is a composite primary key, on the first 3 columns together identifies a record as a unique record. So the remaining 7 columns should be dependent on the first 3 columns primary key. So that relationship should be there. At any stage out of those 7 columns, we cannot say that this column is not dependent on the primary key. They have to be. This is how we design the tables. That is the second normal form. Then it comes to the third normal form. Third normal form says in the remaining 7 columns over a period of time, when the data increases, no relationship should be there among these 7 columns. Out of the 7 columns, if there would be any relationship between 2 columns, then those 2 columns will become primary key and foreign key, and you will break the table into further. With respect to those seven columns, you will take into another table, and then you will create a primary key based on the relationship, and then you will tag it to the main table. So that is how this says duplicate information in a database by creating a separate table. So that's how you, so that is third normal form. In practical, only 3 normal forms comes into picture. There are others also, but they are not much of use in day-to-day business.
Manish, can you explain again the third normal form? So as you said, the remaining 7 columns value grows. That means?
So I'll provide an example of that also, okay, later. Right now we try to see when the value grows, in the sense the data will grow over a period of time, okay.
Okay.
So in between, out of 7, any 2 columns will try to build a relationship among those. So the example, I think that is actually a YouTube, a video I have, very simple, okay. I'll play that, but not now. Okay, that has already the set of table. They have created a table. Okay, so see, to explain that more precisely, we have to take an example. Any table we will take, sales table we will take. There would be different set of columns. Business columns would be there. So how those business columns can develop a relationship between them? The remaining columns. Okay, so once that relationship is developed, so you can relate the data. Okay. So say the ID is 10, there would be some value for that. Okay. Then ID is 20, there would be some value for that. So likewise, when you identify that relationship, that every time this ID comes, the value this is coming. So you will define a relationship and you will break the table into another one. I'll play that video and we will discuss this. I will just show you that practical example of this normalization. See, in our ETL testing or in the project, normalization is a concept which need to be clear in the mind. Okay, there is nothing. See, it's not us who is going to normalize the database. Normalization and everything will be decided by the business and the architect and the database administrators. So as a ETL developer or as a ETL tester, we don't suggest or we don't analyze such things, whether this should be normalized or not. So when you see the data model or when you see your data warehouse schema like star schema, snowflake schema, the tables would be joined like this. So that you need to understand, okay, oh, that means this is normalized. Only that concept. And how any 2 tables are related, always by primary key, foreign key. So this is a concept. This is not something which is done by us, not expected. This is something at data model level, right? So that is first thing. But yes, when you see the data model, if tables are normalized, then you should understand the relationship between them. Okay, this is how they are joined. So that's why they have created a separate table. So this is a concept to create the data warehouse schema and the data model, database model. Okay. So ODS is again, this is an we'll just integrate the data from multiple sources, keep it as a kind of staging, and just for a few days, okay, or just when you try to apply the transformation and all, it's kind of, you can consider this as a staging area. So you'll see the diagram, it will become more clear.
Manish, ODS and staging both are same or different?
See, this creates sometimes confusion, but if I talk about my definition point of view, they are a little different, okay, based on the number of days of the storage of data. But practical data warehouse, if you'll see, there will always be one big staging area. You call it ODS, you call it staging, okay. Data will be staged there. So how many days do you stage? depends when you are going to complete your transformation. Okay, so you complete your transformations. Okay, after that you decide to load the data further into the warehouse. So don't get confused that ODS is something different or staging area is something different. It starts like this: from source you are fetching the data, raw data, putting it into ODS or putting it into staging area. So you keep on extracting it, put there. So this ODS or staging is nothing, it's a relational database again. There would be tables in it. Okay. So if there are 10 flat files, you will try to store data of one flat file into one particular table only. So likewise, you create number of tables based on your source. You store the data, then you transform it, and then finally you load it. Because no transformation happens in the target.
Okay.
Then data transformation is just, it includes the data cleansing, includes the translation of data, aggregation, summarization, what all business logic you have to apply, we apply here. So see, this is the data warehousing component. Okay, this is all your sources: FS1, FS2, FSN. It could be relational databases, mainframe systems, flat files, .csv files. Okay, data is stored in different formats across the organization. You pull it and put it into the staging area. So in staging, there would be all the, say there are 100 tables they have created to store all the data. So all cleansing, transformation, aggregation, they will try to apply here. Okay. And then they will load it into the final data warehouse. After the data warehouse, you are seeing here the data marts. Okay. So once the cleaned and aggregate data is there, on top of that, they will create the data mart. These are further databases which they have created. So the end user is going to have the access here, not here. Okay, this is the main difference. Or in complex data warehouses, in one of the banking projects where I worked, it was a very complex structure. So because banking projects, they have a lot of security issues, a lot of regulatory issues. So they always created a 1:1 replica. So like staging area is there, they created 1:1 replica of that. ODS 1:1 replica, DW 1:1 replica. And all parallel, they all are in sync. So we are given access to the image, not to the actual one. So the image will always be refreshed on a daily basis and you can fire your query there. So QA environment is nothing. In QA, you will always have a replica of production. Remember that. That's why you can move your code to production. So whatever the structure will be there in production, you will create a replica in QA and then you will test it. So this is how actually in production it will behave.
Well, Manish, after you're completing the staging area, does the code will be moved to QA environment?
See, it's not even QA will have a staging.
Okay.
Okay. QA will have the DW, QA will have the data mart also. So whatever you are going to implement in production will be the exact replica in QA. So what development team does initially is the source file will be provided by the business. Okay. So these are my source files. This is my requirement. Extract the data, transform it, load it. So QA in development try to first they will create their job, they will try to run it, they will do a unit testing. So they will take just few sample files. Okay. So few sample files means there will be very less record, 10 records, 50, 100 records maximum. So catching an error is chances are very less in unit testing. They will just make sure that their job runs, it doesn't fail. That is the main purpose. And ideally nobody does unit testing in the industry. The primary reason behind that is nobody has time for it. The time would be very less. Developers will always be, dying to complete their code on time to give it to QA. So they never get, if we are very strict project manager and test manager, no, we want unit test results, otherwise in QA we are going to face problems. So basic expectation from QA is at least the job should run. It's loading incorrect data, we will see. But it should not fail due to some reasons that your programming is in itself is wrong. Your mapping is pointing to some schema, you are trying to load data from some schema, your source and targets are not properly defined in your mapping, then that is a headache for a tester. Why should I analyze such things and point it to, a developer? So once they run their code and everything, they just pass the code to us. We will migrate the code in QA and then try to load it. So we have the source files in QA, we have the staging schema, we have the data warehouse schema available. So just load it. After loading, then we start testing the data. The data is correct or not, the nulls are removed or not. In not null columns, null should not be there, duplicate should not be there. The trimming has happened correctly or not. Okay. And then all the aggregate summarization business rules like that. So guys, this diagram is a typical data warehouse diagram, which you have to memorize it. You have to just visualize it anytime you talk about data warehouse or anything. So this is how it looks like. Okay. So these are all legacy systems. Obviously, your source is your old systems. You call legacy systems. You are extracting data. It's going into your staging area. Forget the concept of ODS. Very rare you will see, ODS in a schema. It's just mainly your staging area, and then from staging it goes to your DW, and after that the data marts are being created.
So in interview we can say that the source for data warehouse is staging. If they ask.
Yes, yes. If they ask that how you were querying the data, he told I was right. When you write a minus query, I was writing between the staging and the warehouse.
Okay.
Then operational process. These are all the different process which are involved: data extraction, cleansing, transformation. Then you do a data load, you do a data refresh in the sense the next day load. Okay, you are refreshing the warehouse on a daily basis, weekly basis. So whatever the business transactions have happened in past 1 week, you will load it on, say Sunday night before the business comes on Monday, like that. And then obviously you are building a derived data aggregation, and then you are administrating the, warehouse. See, extraction, just try to understand one term here, that when you extract a data, you have to write a strategy for that. Okay. How much you are going to extract and when you have to start extracting it. So first of all, you have to decide. Generally, it happens, at midnight, 23:59:59. Okay, that is the time at night, 12 o'clock, just 1 minute before that. So that kind of time is set in the scheduler, and your ETL job will run and will extract the data for the previous business day. So that is incremental load. The first is like initial extraction. So initial extraction, business will decide, okay, I want to build data warehouse starting with my last 10 years of data. Generally, it will be 10 years of data. Okay. that take days to load. Sometimes it takes 3 days, 4 days, sometimes it takes 1 week to load. So in one of my projects, we used to test the initial load also in QA. Why? Because the data warehouse was, so these are the scenarios which can come in interview also, right? So the project was like that. The warehouse was created by Wipro, okay, 3 years back, somewhere in 2010. It was running fine in production, absolutely no issue. It was a small warehouse, okay, with one source only, one major source and a couple of small sources. After 3 years, the same client came to Wipro again. He's already doing business with Wipro in other technologies, other domains. Then he came, okay, you build a data warehouse for me, fine, it's working good. Now we want to accommodate data from a different source also. Okay, so you have to make sure that you pull the data correctly from that source, transform it, load it into the warehouse, and it should not affect the tables which are already there in the warehouse. So there was a big regression testing. Okay, first the scope will be defined, and at the same time, there all the previous loads are going. Okay, so in QA, first of all, to create a replica of a production, we should have the initial data. Okay, if it's an ongoing project, you have it in the beginning, but for the same project, if you are doing it again, so there we asked them all the files which were loaded in production as initial load files way back in 2010. So those files to run in QA, it used to take 3 to 4 days minimum for us. You start the load and 4 days there is no work for you. You cannot do anything. But since they were good files, they were exactly the same files which were used in production, the chances of failure was almost zero. Because that has been something which has been tested 3 years back. It's running fine in production. Okay, so you have the same schema of production in your QA, you have the same set of files, and you also have the same set of ETL jobs also. So obviously there is no chance of failure. But yes, the time it took at that point of time, it is going to take now also. Okay, so that is how the initial load happened. That is how you extract the initial data. Okay, so once you have done that, then you can schedule the job on a daily basis. At night, midnight, okay, it will extract the entire transactions which has happened in OLTP system. So next day when business comes, in their warehouse, they will find the yesterday's data. Okay. There are some business specific, transaction happens only at weekends. So there are weekly loads also. There are some aggregation happens at month end. So there are monthly loads also. There are quarterly loads. There are yearly loads also. So different kind of loads will be there as per business. You will schedule it as a developer. It will be tested once in the QA, and then it will go fine in the production. And then it's business as usual for them. So that's why this term is there, like incremental data. So this incremental data is nothing, your everyday data after the initial load has happened. So next day, how many inserts are happening, how many updates are happening, okay, how many records which got deleted from the source but were already there in the warehouse. So everything needs to be captured. And also, it won't simply load the entire day data when we extract it. So it will first compare. Okay, it will compare. Suppose there are 1,000 records already in the warehouse from last 5 years. Today 10 records come. So it will compare those 10 records first and in the warehouse whether it's already existing or not. If it is not, it will insert it. If it is already existing, then it will update it. Then again update happens through different process, SCD type 1, SCD type 2, which are the most important in ETL testing and development, which will be covered later. Okay, so I'll tell you how the updates happens in the warehouse, how the insert happen in the warehouse. So right now just remember initial load, incremental load. Okay, initial extraction, incremental extraction from the source systems. So this is how you are taking it from source to staging area, incremental data. So periodicity of transmission, daily by weekly, depends upon the feed system. So it depends upon your business, the source system. And then your transformation process, which is coming into picture. You see all the mapping detail transformation will be here in the transformation process. And every time the metadata will be, observed, you will be preserved in the metadata tables. You create a new mapping, it will point to the metadata also. So Informatica has specific metadata tables. So generally this is for Informatica admin. Sometimes we require some informations. Okay. So what admin will do, he will just query the metadata tables and he will give us that information regarding the mappings and other things. So we need not to, as a tester or a developer, need not to concentrate much on the metadata part. Then how the weekly data, monthly data, and yearly summarized data is stored in data warehouse, it all depends on the data warehouse schema fact tables. Let me see, where is the architecture slide? Okay, we'll just quickly walk through these slides. See, these are typical industry terms which you may find, while you browse the internet and all. So normally at corporate level, we will find the EDW. This term is the most common, enterprise data warehouse. So it's enterprise wide in the full organization. Okay, data mart. Okay, these two are the relevant terms. The others are some theoretical terms which have been picked up just for knowledge base. Virtual DW, distributed data marts, multi-tiered data warehouse. So we'll focus on EDW and data marts. So see this virtual data warehouse, how this concept is going. By seeing the diagram only I can relate here that there is some application through which you are accessing the data from all the sources, and then they're calling it a virtual DW. Not important at all for us. This is a typical EDW looks like. Okay, you have your OLTP systems, you have your some client server models, you have some external systems, you have some IBM mainframe legacy systems. Okay, you are extracting the data, transforming it, integrating it into the final data warehouse. And always there is a metadata repository which will be involved for database, for ETL tool, both. On top of that, there is some BI tool through which users are accessing the data. So this is same thing which we just discussed. So just give me a couple of minutes. We'll next start with the schema of data warehouse, like star schema and snowflake schema. I want to show you so that we become clear how the data is being stored in the warehouse. So this is data in a data warehouse. By seeing this, it's not much clear. Okay, so this is like current detailed data, lightly summarized, highly summarized. So how this summarization happens, on which table will decide which table will store the summarized data. So that is a fact table, right? So what is a dimension table, fact table? I'll just show you the diagram. Just give me 2 minutes. So guys, you are able to see the screen? Yuvraj?
Manish.
Yeah, Manish.
Yes, Srinivas. Okay. So guys, this is a typical a star schema. Okay, so what are the important things here needs to understand? This is how the actual data model looks like, how they created these square diagrams. Okay, so in these square diagrams, here always the name of the table will be there. Then there will be primary key and the ID columns. So this looks like a star because this is a center table. These are all dimension tables. 1, 2, 3, 4, 5. These are the 5 dimension tables. Okay, and all these dimension tables will be connected to a central fact table. So the question comes here is, what is the relationship between dimension and fact tables? So remember, any table will have a primary key. That is the first thing to hold the data. So all the dimension tables will have a primary key. So dimension table is something which is the data we have taken from source, transformed it, extracted, transformed, and finally loaded. So this is in warehouse. Remember the schema. This is so here generally the warehouses are built in star schema. Remember, but over a period of time they gets converted into snowflake schema. The dimension tables will grow. These are the tables which you normalize. You don't normalize the fact table. You normalize the dimension tables. Dimension tables are always loaded first. Then the fact tables will get loaded. So this is how the Informatica workflows will be there. First you load all the dimension tables, then the fact table gets loaded. Okay. So all the key columns of the dimension tables, these are going to be the as a foreign key in the fact table. So that is how the relationship is. So the primary key of the fact table, okay, this will contain all the PKs of the dimension tables. So if you will see, if the first PK is ID1, the ID 1, 2, 3, 4, 5, for all the tables it is there. Okay, this is how these tables are related. So now, if you start a join, okay, if you write a join on this star schema, okay, so say if you have to retrieve some information where these two tables are involved, 1 and 5, okay, so fact is the center table. This is our driver table. Okay, we are fetching information from fact table. So this fact table will be joined with this table. Condition would be on dimension 1 dot id1 is equal to fact table dot id1. Likewise, for fifth table, it will be id5 versus id5. Join on these two. So another important thing here is for the fact table, we are going to have the measures. Okay, we don't have all the information. So dimension table, you can imagine like a product table. So this is a product ID. These are different products which you are selling in your retail store. Okay, one is a time dimension, one is a geography dimension. What all different locations your stores are. Okay, so one is customer, which is very important. Okay, so all your customers would be listed. One is your order table, so a different kind of orders which are being maintained with respect to a customer. So all these will be your different dimensions. Here what will be stored? Sales, how much sales has happened, aggregation in terms of sum. Okay, so last 7 days, how much is my sale? Every day, hourly, how many are my sales? So this kind of information will be there. This is what we call measures, aggregation, right? And the primary key of the fact table would be a composite key, okay, containing all the keys of the dimension tables. Only then you can join, otherwise you cannot join the tables. So in reality also, once you refer the diagram, this is how most of the times as a ETL tester you may have to understand the data model to get your join conditions specifically. In Snowflake schema, what will happen? These dimension tables, not all, but some of them may get broken into other tables. So there is a square box, there will be another square box, there will be another. So these tables will be joined. So data warehouse, you don't simply take it as a database that okay, there are 100 tables, simply there are 100 individual tables, I will query them, I'll get my results. No, those 100 tables will always be related to each other with respect to such schema, star schema or Snowflake schema. This is how it won't be a single fact table and there would be 99 tables attached to it. No, there would be multiple fact tables, okay, depending on the business, what kind of summarization they are doing. And all the fact tables also will be joined together, and every fact table will have some dimension tables on top of that.
Indeed.
So likewise the schema goes on.
So as you said, all the fact table and the dimension table will comes inside the data warehouse, or it comes as a data mart?
Both. Okay. Data mart will contain the schema with respect to the subject area only. So for HR department, say there are only 2 fact tables. So it will only cut. See, data mart is kind of a view. Okay. It's a view on top of your data warehouse.
Okay.
Which you are refreshing daily. So for me, end user, I can see only 2 fact tables and 5 or say 10 dimension tables. That's it. So it's a restricted access. You can take it as like the definition of view, the term view you understand in database, right?
Yeah.
So it's more or less the same thing.
Okay. So normally while forming the data warehouse, they will form the they will start with the star schema, am I right?
Always, yes. Because initially nobody knows that which table is going to get duplicated, which table is going to get big over a period of time. So generally they will start with, in almost all cases, with star schema only.
So initially once the data grows, it will be moved to the Snowflake schema.
Yes, it will be ultimately converted to a Snowflake schema.
So there comes the third normalization.
There comes the third normal form. Yes. So it now depends to what degree are you going to normalize it. So generally first and second normal form are just, part of database definitions. Like every cell should have a single value. All the non-key columns should be dependent on key columns. That happens in every table.
Okay.
So where the table actually gets broken is the third normal form.
As you said, from the dimension 5, it may be broken into some other dimension. So there comes the third normalization.
Yes, but those dimension tables are not linked to fact.
Okay,
They will be linked to that dimension table only. Yeah, that will be to that dimension table only, not to this. I'll just show you the diagram of Snowflake also.
We cannot see your screen, Manish.
Yeah, just 1 minute. Guys, see this diagram now. Able to see?
Yes, Manish.
Yes.
So this is a typical Snowflake schema. Okay. So try to understand here. First, there is a central fact table, sales. Okay. There are different dimensions attached to it. So we'll first see the star in this, then we'll see the Snowflake part of this. So if you see the star part of this, we have a dimension called date. Okay. It has a ID column, primary key column. Then it has different columns. What a date table can contain? It can contain date, it can contain day, day of week, month, quarter, year. There is a store dimension table. There is an ID column first to define the primary key. So there will be a particular store ID, obviously. Okay, it has to be unique. Then there are store number, geography ID. Then there is a product table. It has a product code, then some EAN code, some product name, like that. Okay. Then there is a dimension product category. Now, what has happened over a period of time? Initially, there was only dimension date, dim store, dim product. Okay. So there are number of stores now, and there is a geography ID also. Now, further, what they decided is that, okay, let's break down these tables in further in another table called, say, particular geography table only. So what this geography table will contain? It's contain only the state and the country. So the same information is getting captured with respect to the geography ID in the initial table also. It becomes redundant. That's why we call it becomes the same information is available. So they identified that there is a relationship, okay, between country, okay, or the name of the state with respect to the geography ID. So that they try to create it a new table altogether, so that such information, such relationship we can always capture in a different table. So likewise, if you see, there are products with different brands. Okay. So to a particular brand, they gave a particular ID. So this ID is always a generated column, right? Generated column in the sense this will be your primary key. So they took the brand all together in a brand table. They took the product category all together in a product category table. They removed it from the initial product here. So initially, if you see, we have the product name also, we have the product category ID also, we have the brand ID also. So brand ID, there would be a name also with respect to this. So they took it in a different table. So this is what they have normalized it, and they will always be linked. This ID column will be joined with brand ID because this is for the brand table. This ID column will be joined with product category ID column. So this is how these three tables will be joined in all together. So the fact table will always be joined with respect to the dimension tables. The ID column of dim date, this ID column will join with date ID. This ID column will join with store ID. This ID column is going to join with product ID. Then there is a measurement column, aggregate column, which we call units sold. So how many units are sold every day, or maybe monthly, or maybe weekly? This is called, we call summarization. So you have to summarize the data weekly, yearly, quarterly, monthly, like that. So generally in BI part, you'll see a lot of such terms. Okay, summarization is happening. So you have to create a report like that. Summarized reports are there. So those reports ultimately fetch data from here only. So actually, this is a very nice example which I found few years back, and I always give this in classes and even the batches which I train in my company also, right? So this is a very simple, generally you won't find in any study material in across any institutes and all. It is there simply in Wikipedia. Okay, snowflake schema, this diagram which we just discussed, and this is the join. So this is in such a simple way that it will clear your concepts. Okay, always. So when say you try to see this, you always try to select the summarized data. That is why you are creating the warehouse and the fact table. So you are selecting from the fact table F. What you can select? Obviously, you select the sum of the units sold. Okay. Also, you are selecting few columns from the dimension tables. You are selecting brand, you are selecting country. So country wise, the business statement is country wise, which brand is getting sold on a weekly for how much. Okay, what is your aggregation? That is what you want to see. So if you want to retrieve this information, okay, if you want to retrieve this, so see, this is the business statement. Total number of units sold with respect to each brand and with respect to the country in the year 1997. So business wants to see, okay, 20 years back, what was our trend? Okay, so this is the SQL query they have to write, but they cannot write complex SQL queries. And this is actually speaking not even 1% of the actual real-time queries which you will see in data warehouse. They are going to be too big and too complex business. Okay, financial sector have their own complex business, retail, insurance, all. So there is the queries will be huge and other thing. But if your concepts are clear, you simply have to join that correct table. Which table I have to join with which other table? Okay. So if that is clear to you based on the data model, based on your concepts, based on your mapping document, you can even write 500,000 line queries. At times you have to write 100, 200 queries, 200 line SQL queries. So you can all it takes time to write, it takes time to execute. But as a tester, you will get that time. Okay. But you can only write if you understand what you have to join. Right? So here we have the schema in front of us. We know the brand is coming from which table. It's a normalized table, okay, with respect to the product table. So country is coming from the another table, G table. Then F table is of main fact table. So now this fact table we have to first see the brand is coming from which dimension table. That dimension table has to be joined with F. So here we are doing inner join. Okay. So the brand was coming from product. So inner join products P. First we are doing this join P. Okay. On the product ID should be equal to the from the fact table the product ID should, so here it was there, this product.
Manish, your voice is breaking. I cannot hear you, Manish. Ishwar? Ishwar, are you there?
we were discussing was the snowflake schema. Okay. So see, the whole concept was to understand first the data model. Okay. First to identify how the tables are done. First to understand the dimension table and any further normalized table associated with a particular dimension table. Try to understand their keys, primary key, foreign key relationship, which ID is being joined with which table. Once that is clear, then you go with the fact table, how the dimension tables are connected to the fact table. Not every time you require all dimension tables to be joined with respect to fact. What information is required, based on that only you will join. Okay, so like here we wanted brand and country. So first we have to see from where the brand and country fields are coming. Date is something which we have to join by default, okay, because over a period of time we want the data. So date will be joined based on the data ID column, okay, the ID column of the date table with respect to the date ID column of the fact table. So that is their relationship. Likewise, the store based on store ID, geography on geography ID, product on product ID, and then brand ID. So the normalized tables will be joined with respect to their dimension table. So this is where this understanding of this relationship will come into picture. So there are two tables here. We have the brand, we have the product category ID. So these tables cannot be joined with the fact table. Remember, okay? These tables will be joined with respect to their dimension tables. And then you give the condition where product category is your TV, year is your 1997. And then since it's an aggregation, so you have to do a group by. So in the select statement, whatever the columns are there other than the aggregate column, so you have to do a group by on that column and you will get the result. So this example, I would suggest if you get time today, just try it for star schema as well as for snowflake schema. Try to go to the Wikipedia, it is there. Open that diagram first and then see the SQL query and the problem statement. In case there are any doubts in that or you are not able to understand, maybe in terms of SQL you may not be able to understand at this point of time, because SQL will be covering all these joins and important group by and summarization and everything later, okay? But still, at least try to relate it what you can get. This is like over my career I have found this a very simple example, okay, to start with, okay, just to understand the concept of star and schema with respect to the SQL involved and the data model involved. So at one place you are getting all these three things. Definition is there, data model is there, all the joins are there. Okay, so just spend some 15 minutes each on these two schemas and you'll get a very better idea. In case there is any doubt, we will discuss it in tomorrow's class. Okay, because this is where will be the base for us. So concept wise, I'll see what all other important things which we can be discussed, because there are many things which will be discussed parallelly, while we are working on the SQL and we are working on the actual practical scenarios I'll share from my previous projects as I discussed earlier. Okay, so there are many concepts which will be revisited every single day going forward. So don't think what we have covered will not come into picture again. No. So anything which is required just to start with, I'll try to wrap it up by tomorrow. Okay. After that, we will completely go into the SQL for a week. Okay. Try to cover all those things. Then we will start with, and during SQL, we will definitely have the server access and client access, so that, we will write the SQL queries and we see the result then and there. So that I will that we have at Tek Classes. After SQL, we will go into all the real-time scenarios, the real-time business statement from the previous projects, what SQL we wrote, what mapping documents we had, what as a tester it is required for you to test, what in the interview they can ask. So likewise, all the real-time scenarios will be discussed. Okay. Still, there are many important concepts which are remaining. Theoretically, I will cover tomorrow. Okay, with respect to SQL and others. Then in the subsequent weeks we will cover. Yes, tell me, you are asking something.
Yeah, so I want to confirm, so every day, so how many hours will be the session, Manish?
See, I'm not sure about how much I will cover on every day. It depends. Sometimes it may go to, up to 1 hour, maybe less than 1 hour, sometimes maybe more than an hour. The total number of hours are stated as 25 to 30 hours for this entire course. Okay.
Okay.
But
Okay.
my intention is not on the number of hours. Number of hours may go to, 40 also. Okay.
Okay.
What I have to cover, I will cover. Okay.
Okay.
Maybe even if it takes little less time, it is okay. Even if it takes more time, it is okay. But there's nothing, any concept or item which I will try to leave. Okay, no.
Okay.
So we'll try to cover up everything. We'll try to start, at the same time every day, 7:30 to 7:45. Like that is my time in India here. Between 7:30 to 7:45, we'll start. Weekdays I prefer. See, even today I didn't see the time. It's now 1.5 hours almost. Okay, so I can plan for 1 hour also, but I'm not planning hourly. I'm just planning what I have to cover. So that takes, even if less than 1 hour, I'll wrap it up that particular class. Okay. So don't worry about it. Approximately you can consider 1 hour.
Okay.
1 hour every day.
Because I don't want to rush up the hours, as you said. We can just go gradually, and we need to cover all the topics. So
exactly. Yes. Sometimes it could be more. Sometimes it could be even less than 1 hour. So it's just that we have to cover. So and gradually we have to cover. It's not that all the complex things I can cover quickly and no. So whichever will take time. Sometime even if one day is taking 1 hour class just for one concept, it is absolutely fine. Okay. I'll try to share that YouTube video for normalization that some guy has prepared in a very simple language. Okay. So I'll see some other video also, because the concepts you can only it will settle in your mind once you actually see a particular table. Okay. Yes. But still, just try to see something also. Like these two things you try to study of your own today. Okay, these are very simple examples to start with. It will help you a lot. Right. Okay. So many people they don't understand the data model, and they don't even figure out how they are going to write the joins. So just see this, and we'll conclude tomorrow. Then we'll start. Okay. So for you, it's only weekdays is fine, or you also opted for any weekend or anything?
Weekday will be fine for me, Manish.
Okay. Fine. Okay. Any questions further?
No, as of now, I'm finished.
Okay, fine.
Our training videos will be recorded, right? Then we will be sharing, right?
I think they are recording these videos, yeah.
Okay.
But you won't see, this may not be that systematic always, because we will try to focus what we want on a particular day. Okay, but yes, I think they are recording all. I can see the recording button being involved.
Okay.
So definitely these will be shared. And also all the the PPTs and other study materials, and also the links from where to study and what to study. And I will try to see if any the real-time documents which I have, that also I'll try to share. Okay, so that you can refer those actual test plans being involved in the industry, actual documents also. Okay, so those we'll share once we cover it. Okay.
Okay, Manish.
Yeah. Thanks for joining.
Okay.
Bye.
Thank you, Manish. Yeah, thank you.